Alright, so now we are moving on to our last section of Chapter 8. We're just talking about identifying these special types of quadrilaterals. So basically what properties are shown and so then what shape is it. And I kind of mentioned this at the beginning of the chapter, but we're going to end up making what is called a quadrilateral hierarchy. And it's basically just this fancy flow chart. So to start, the broad topic that all of these fit under is quadrilateral. Every shape we've talked about in Chapter 8 has had 4 sides. So that was the big broad topic we talked about. And then the first quadrilateral we specifically started talking about and learning theorems on was a parallelogram. That was the big broad one. And then from there, well, we said, okay, well, there's these 3 other shapes that fit into this parallelogram category. One of them was a rectangle, and the other one was a rhombus. And we said a rectangle, was a parallelogram with 4 right angles, and a rhombus was a parallelogram with 4 congruent sides. And from there we said, well, a parallelogram with 4 right angles and 4 congruent sides was a square. And before we kind of talked about this as a Venn diagram setup, if you guys remember seeing that, but it works in this flow chart as well. We have all these different types of parallelograms that are just, in fact, quadrilaterals. And then back in section 8.5, we learned about 2 different types of quadrilaterals that weren't parallelograms. And the first one was a trapezoid. And from there, we said, okay, we have just a normal trapezoid, but we also had a special type of trapezoid called an isosceles trapezoid. And we knew that the isosceles trapezoid had some specific properties about it that a normal trapezoid didn't. And that's kind of where we stopped there with trapezoids. And then as you guys can kind of see up here in this picture, our last type of quadrilateral was a kite. And we really didn't branch off of just a kite more than that. So here's our quadrilateral hierarchy. And what's nice about this is that each shape in the diagram has the properties of the shapes linked above it. So a square has all the same properties as a rectangle, a rhombus, a parallelogram, and a quadrilateral. An isosceles trapezoid has all the same properties as a trapezoid and a quadrilateral. And it works the same for a kite. So basically it works from bottom to top. So if we have a square, we also know that it could also be a rhombus, a rectangle, parallelogram, or just a quadrilateral. So when I'm asking you what's the most specific name, you want to take a name that's from the furthest down the hierarchy as you can. And then when it asks for all the names, that's when you would start working up. And we're going to kind of use this, so make sure you guys get this written down somewhere in your notes. This is very important. You probably don't need the pictures drawn here as long as you're familiar with the names. But this is going to help us answer a lot of questions in this section, so make sure you guys pause this video and get this written down. Everything else from here is just examples. So let's go ahead and keep working on those. Our first example here is just asking us to identify a quadrilateral. So we have quadrilateral ABC has 1 pair of opposite angles congruent. At least 1 pair of opposite angles congruent. Well, if we think about that hierarchy there, let's start with our more broad shape, the parallelogram. Let me bring this back up. Well, think about a square, opposite angles being congruent. All the angles in a square are congruent, so they're all 90 degrees. So it could be a square. And if we move up the hierarchy from there, we know, okay, well, if it's a square, that means all of these also have that in common, so we could say rectangle, rhombus, and parallelogram. And with that list, we've kind of exhausted our first section over here. So then let's see, okay, are opposite angles in a trapezoid congruent? Well, no, they're not. We know that consecutive angles are supplementary, but in a trapezoid, especially isosceles trapezoid, we know the base angles are congruent, so we can't have trapezoid in our list. And then we come to a kite, and if we remember from section 8.5, we said that there was one pair of angles, opposite angles congruent. It was that pair right there. So a kite would also fit into this list. And that's kind of what I would be looking for these types of problems. It's just kind of a list of what quadrilaterals meet that condition. And I would be looking that you had all 5 options there. And that's a common type of problem, just kind of making a list. And do you see how easily we were able to use that hierarchy there to kind of help us with that? That's why it was so important for you guys to get that written down. So then moving on to our next example, what is the most specific name for quadrilateral ABDC? And looking at it over here, it looks like a square, but we can't assume that. And we can't assume that because we don't know that these are 90-degree angles. Even though they make it look like that, we don't know that for sure. All we know is that the diagonals bisect each other, and I know that from these congruent tick marks. So I know that the diagonals bisect each other, which was one of our theorems we learned way back when for a parallelogram. And since I don't know if the diagonals are actually congruent to each other, I don't know anything about angles, I don't even know if those diagonals are perpendicular, the most specific name I can say for this is actually just a parallelogram. I would need more information to go further from there. So that one is just a parallelogram. So then, keep moving forward here. Got just lots of examples today. Another identify the quadrilateral question. They're asking, is enough information given in the diagram to show that quadrilateral PQRS is an isosceles trapezoid? It's not just a trapezoid. They specifically want us to say isosceles trapezoid. So the first thing I want to do, just kind of looking at this picture, is I probably should figure out what this angle Q is right here. I know that these base angles are congruent, but my first step here would be to make sure that these base angles are also congruent. So I'm going to use the fact that all 4 of these are going to equal 360 and just do a little subtraction. So 360 minus 74 minus 74 minus 106 to get that angle Q is indeed 106 degrees. So I do have that 2 pairs of base angles are congruent. And then just to kind of further that explanation, to show that we only have 1 pair of parallel sides, I kind of can think of, okay, which pairs of angles are supplementary? And this is kind of just going above and beyond. 74 plus 106 equal 180. Since those are supplementary, I know that PS is parallel to QR. But looking at 74 plus 74, that's only 148. Which is not 180, which means those aren't supplementary, so we can't say that PQ and SR are parallel. So, since I'm going above and beyond here, the fact that we have two pairs of congruent base angles, we could say since there are two pairs of congruent base angles, it is an isosceles trapezoid. And you may ask, why did I do all this extra work? Well, this proved it was a trapezoid in the first place, right? Because we know a trapezoid only has one pair of parallel lines, and back in section 8.5 we talked about showing that it only had one pair of parallel lines, and by checking which pairs of angles added to be 180 told us that we only had one pair. So they kind of work together. I just kind of jumped straight to the conclusion at first without doing like the little mid-step to get there, but this would be our reasoning why it's isosceles. The fact that there's only one pair of parallel lines tells us it's a trapezoid. So they kind of work together to build that, to build all the information you need. So it all kind of works together, and that's why we had to do both. Our next example here is a little guided practice question. Why don't you guys go ahead and hit pause on the video so you guys can work through this on your own and come back when you've had a chance to solve it to check your answer. Okay, quadrilateral DEFG has at least one pair of opposite sides congruent. What types of quadrilaterals meet this condition? Well, one pair of opposite sides congruent. I'm going to get my quadrilateral hierarchy back out. I'm going to start with that parallelogram section again. Well, a square has at least one pair of opposite sides congruent, right? All four sides are congruent, so a square would fit here. And then going from there, well, if it's a square, it's a rhombus, rectangle, and parallelogram. And just like I did before, I kind of exhausted this option here. So I'm going to jump over here, start with isosceles trapezoid. Well, isosceles tells us that we have two congruent legs, and the legs of a trapezoid are opposite of each other. So at least one pair of opposite sides congruent, that fits that description. So this would also include isosceles trapezoid. So then I kind of work up from there. Well, doesn't necessarily include a trapezoid, because in just a normal trapezoid, not always congruent. We have at least one pair of sides that are parallel, but not always congruent. So this is that one rare occasion where you just can't go up the list, is with the trapezoid, because an isosceles trapezoid is very, very specific with having the side opposite leg, the legs being congruent, very specific. So then moving on to kite, well, those are consecutive sides that are congruent, so it wouldn't be a kite. So again, isosceles trapezoid is kind of that weird case. Over here, it's really easy to just go up. These kind of all flow with each other very easily. But right here, this isosceles trapezoid, you got to be careful with. Sometimes you can just go straight up, especially if it's talking about parallel sides. But with congruent, opposite congruent sides, it's only one. That's not necessarily true with just a normal trapezoid. All right, so we're going to keep moving on. Almost done. A few more examples. Another guided practice questions. Why don't you guys go ahead and pause the video and try this one on your own as well. See if you guys can piece that together. Come back when you're ready to check your answers. All right, give the most specific name for the quadrilateral. Explain your reasoning. Okay, so looking at number 2 right here, I see that those 51s are congruent, and we have our 50s congruent there. And they're not opposite sides, they're consecutive sides, so this would be a kite, because it has two pairs of congruent consecutive sides. And then number 3 over here, we see that we have one pair of parallel sides and not a second pair, so that one pair of parallel sides tells us it's a trapezoid. And then number 4, to wrap things up, we see that we have this pair, opposite pair, congruent. This diagonal is bisected, but we have nothing to go with the 9. So thinking about all these theorems we've talked about, it kind of seems like we have a lot of part of the information for like multiple theorems here, but we don't have enough to actually fulfill any of the theorems. So the most specific name we could give this side is just a quadrilateral, because there's not enough information. And again, to re-emphasize that, I say this because we don't know that both diagonals are bisected. We don't know that we have two pairs of opposite sides congruent, and we know nothing about angle measures, so the most specific name we could give this is just a quadrilateral. So then our last example here, why don't you guys go ahead and hit pause on the video and try this one on your own. All right. A student knows the following information about quadrilateral MNPQ. MN is parallel to PQ, MP is congruent to NQ, and angle P is congruent to angle Q. The student concludes that MNPQ is a isosceles trapezoid. Explain why the student cannot make this conclusion. I'm a very visual person, so I'm going to go ahead and draw a picture. We have a quadrilateral, so I'm just going to draw a basic quadrilateral. It could be a parallelogram, trapezoid, kite, but it has 4 sides, so I'm just going to go ahead and kind of draw it in like that. Label my corners here, going in order, M, N, P, Q. And I'm going to kind of go through and label what they tell me. MN is parallel to PQ, okay? So I'm going to draw in my little arrow here. Those two guys are parallel. MP is congruent to NQ. So those are my diagonals, right? MP is congruent to NQ. So those guys are the same. And then angle P is congruent to angle Q, which means these guys are the same. So looking at this, they never tell us what this exact angle measure is, but we don't know the measures of angle M and angle N as well. So looking at this, could it be isosceles trapezoid? Yeah, it could be. We have a pair of congruent base angles and diagonals are congruent, but it could also be a rectangle because that has 4 congruent angles. Well, we have 2 of the 4, and the diagonals are also congruent in a rectangle. And to know for sure whether it's a rectangle or not, we would need to know the relationship between MQ and NP. We would need to know the relationship of these sides to know if they're congruent, parallel, not parallel, before we could decide between the two. Basically, we've narrowed it down to these 2 options, and we just need to be able to decide between the 2. And that wraps up Chapter 8. That was our last example for Chapter 8. Here are the homework assignments, honors. You guys are doing page 546, number 3 through 11, 14 through 16, 18 through 20. 3 through 11 is a table. They're going to ask you to copy down the table, and then you're just kind of putting X's in if it fits the relationship. So I would have your hierarchy out to help you with that one. And then CP, same page, 3 through 11. Again, you're doing that table. Use that quadrilateral hierarchy to help you, and then 14 through 16. Always email me if you guys have any questions. This is the last section of Chapter 8, so it's putting everything together we've learned in Chapter 8. So look back in your notes, look through the textbook if you need help as well, and let me know if you have any questions.